Hello everyone, my name is Denis. It's no secret that many owners of Xiaomi M365 and Pro would like to increase the range and speed of their scooter. This can be achieved in two ways. The first is to replace the original battery to a more capacious and high voltage one. Or the second way is to keep the original battery but install an additional external battery. In this video I will show you how to install an external battery on a scooter, and this battery can be flexible mounted and took off at any time without voltages aligning. We can even use a higher voltage external battery, for example 12S. Look, this is Xiaomi M365 with a regular 10S battery inside and an additional 12S battery outside. I will show everything on this example, but this is also relevant for the Pro version of the scooter. Let's disconnect the external battery now and start without it. Then turn on the scooter and watch it via the smartphone application. Press the throttle starting the motor from the built-in battery and try to hot plug the external one. You can see that speed rises, and this is predictable. The external battery has a higher voltage. Pay attention to the smartphone screen. When the external battery is disconnected, the internal battery voltage is displayed, 38 volts. And when I connect the external battery, the scooter recognizes it and displays its voltage, almost 50 volts. This is a very simple and logical algorithm. Why had nobody done it before? The whole YouTube is full of videos about connecting additional batteries, and always people have to align voltages of the internal and external batteries, flash the main controller, and still get an inconvenient result when the external battery is tightly connected to the scooter, and it cannot be removed, recharged and returned back if necessary. Of course, they never used external batteries with increased voltage. To find out this, we have to spend a little time and understand the issue of parallel batteries connecting from the basics. Let's take a battery and connect the simplest load, a lamp, which will glow until the battery is empty. It has discharged very quickly, and we decide that we need to increase the battery life. To solve this problem, we take another same battery, fully charged both, and connect them in parallel. Now you can see that current consumption is shared between the batteries, and each battery charge is being consumed twice as slow. Perfect, we have connected the second battery and doubled the battery life. Looks like everything works. We found a way to connect an additional battery, and here we can cut the video off. But as usual, there are some difficulties. Let's go a step back and imagine that the batteries are still the same, but first battery is full charged and the second one is half charged. The problem is that battery's voltage depends on its charge level. And if the battery is supposed to have a nominal voltage of 36 volts, that means that a fully charged battery has a voltage of 42 volts, which gradually decreases during discharge, until it reaches the level of 30 volts in a fully discharged battery. That's why our fully charged battery has a voltage of 42 volts, and the half-charged battery has a voltage of about 36 volts. What will happen after we connect these two batteries in parallel? Well, if you are not an expert of electronics, just believe that electric current behavior in wires is much like the behavior of water in pipes. If you take two glasses with different levels of water and connect them with a tube, the water flows from a more filled glass to a less filled one until the levels are equal. Our batteries behave similarly. The current flows from more charged to less charged and flows until the battery's voltages are equal. And this charge transfer can be a big problem, because the current between the batteries reach significant values, while lithium batteries cannot be charged with current above a certain level. As a rule, the battery's charge current should be less or equal to its capacity. So, for Xiaomi M365 it is 8 amps, and for the Pro version 12 amps. The bigger voltage difference between the batteries, the more current flows. In our experiments, at the moment of connecting the batteries, the current goes over 20 amps, which of course is unacceptable. But as the voltages align, the current decreases, and at a certain moment it is within normal limits. So we come to the conclusion number 1. In general, batteries can be connected in parallel, but there is an important restriction. Their voltages must be almost equal at the moment of connection. Let's proceed to our electric scooter, and it's a bit more complicated than a simple lamp. Firstly, the main battery is not connected to the load directly, but equipped with a BMS board, which protects it from various problems: overcharging, over-discharging, disbalance, and short circuit. Secondly, the load is not a simple lamp, but a scooter controller that is constantly connected to the battery and also connected to the BMS through the data lines, exchanging information with it. Well, how does it all go? We push the throttle. The controller requests the battery state from the BMS. The BMS responds to the controller by transmitting the requested information. The controller makes sure that everything is fine and starts to spin the wheel. Okay, we finished with boring things and moving to the interesting ones. Let's connect an additional battery in the most popular way, through the Y cable. The external battery is a little more charged than the internal one, so at the moment of connection a small current starts to flow, for example 1 amp. As we found out before, such a small current is not dangerous for the battery. But there is another problem. We push the throttle, the control asks the BMS for the battery state, and the BMS reports that the charging process is ongoing. And the scooter doesn't go, because it has a limitation in its firmware, not to go while the charging process. Fortunately, this problem was successfully solved by some clever people. They made a custom firmware with disabled charge detection function, so this small current between the main and additional batteries does not block the scooter. The BMS, as before, reports that the charging process is ongoing and it's impossible to go, but the controller ignores this and the scooter starts moving. But what if connect an external battery with a voltage perfectly equal to the internal battery voltage, or just wait until the voltages are self-aligned? Does this allow to avoid firmware patching? No, it doesn't, and that's why. Imagine that we waited until the voltages aligned themselves, the charging current stops and the scooter goes. But the problem will appear a bit later. Due to the fact that the battery's different characteristics, their voltages will disbalance during the discharge process. For example, you passed 5 kilometers, stop at the traffic light, and the scooter falls into charging mode again and stop going. You will have to wait a few minutes until the voltages are self-aligned again. And we came to the conclusion number 2. For Xiaomi electric scooters, it's not enough that the batteries have the same voltages at the moment of connection. You also need to patch the main controller to avoid charging process detection, otherwise the scooter will not go. By the way, this problem of false charge detection can be solved not only by patching the firmware, but also by soldering. You can make a tricky move and connect an external battery bypassing the BMS. In this case, the charging current is not detected by the BMS. We push the throttle, the control asks the BMS for the battery state, and the BMS honestly replies that it doesn't see any charging process, and the scooter starts moving. In practice, it looks like this. The additional battery is soldered directly to the contacts of the original battery assembly. Well, here everyone decides for himself what's easy for him, to open and solder an original battery or to patch the controller firmware. And the conclusion number 3. You can connect an additional battery in parallel to the main battery, both before and after the BMS. All these methods have advantages and disadvantages. So, we have reviewed the main problems of connecting an additional battery in parallel to the main one, and the general conclusion can be made as follows. If you take an extra battery, align its voltage with the internal one, connect it and patch the controller firmware, this works fine. The most annoying thing that the extra battery is tightly connected to the scooter and you cannot mount it or take it off at any time you want. But it would be great. You go to the nearest store for bread, leave a heavy additional battery at home. And if you are going far, connect an external battery and go. Or another situation, you go to the office, leave the scooter outside and take an external battery with you to charge it. Shortly, it's a very useful feature to be able to connect and disconnect an external battery at any time without need to align the battery's voltages. Let's try to invent a solution to achieve this. A simple Y cable is not enough. And the first solution that lies on the surface is to connect the batteries not directly, but through diodes. A diode operates like a valve for electric current, passing it in one direction and blocking it in the opposite direction. Let's connect positive leads of the batteries through diodes. And it looks like we found a solution. Batteries can no longer charge each other, while they can perfectly power a scooter. But if you try to do this with a real scooter, then its controller will burn out at the first braking. The thing is, the scooter controller not only consumes battery current, but also sometimes recover energy back when braking. And if the batteries are connected through diodes, then they don't pass the recovery current, and this leads to the following. The energy recovery current has no way to go, the voltage on the controller rises up, and the controller burns out. Therefore, 2 diodes are not enough. We need any smartest circuit that doesn't pass current between the batteries, but freely passes the energy recovery current. This circuit should analyze the voltage of each battery and the voltage on the controller, and based on this, make a decision in which direction to pass current. In idle state, not to pass current from the more charged battery to the less charged one. During acceleration, pass current from the batteries to the controller, and pass the current back while braking by energy recovery. This circuit also must be connected to the data line and provide information about the external battery to the main controller. Well, I am proud to inform you that I have implemented this circuit in hardware. Here is a compact black box with a lot of wires coming out, but if you watch it closer, then everything will be simple and clear for you. These 3 wires go to the internal battery. 2 ones to the controller. This one to the charging port. And the last connect is for an additional battery, which goes out of the scooter. Now let's install the device inside the scooter. Remove the cover and completely unplug the internal battery. Power connector, data line and charging connector. Try the future device location, it fits perfectly in front of the controller. Let's start the installation by laying the extra battery cable out. Remove the rubber plug, take a piece of hard cable and lay the extra battery cable out. Before pulling the wire out completely, plug the charging port connector. And now finally put the device into the space in front of the controller. Let's start to connect the rest wires, and the first one to connect is the power output of the internal battery. Next, connect the data cable from the adapter to the controller. Then the data cable from the battery to the adapter. Connect the charging plug of the internal battery. And the last cable is the power input of the controller. Make sure that nothing sticks out above the deck level. And close the cover back. I am tightening only a few screws, because I will open it again soon. Insert the rubber plug back, and of course first you need to expand its hole for an additional couple of wires. Finally, everything is ready to connect an external battery. Let's check what this system is capable of. I counted as many as 5 use cases. 2 of them are the most common, and 3 are exotic for crazy geeks. The first option is when the external additional battery is not connected and the scooter is powered by the original internal battery. This option is useful to go somewhere nearby. Of course, the range and maximum speed are like a scooter out of the box. The second option is to connect an additional external battery. Exactly, this is the main operating mode. Depending on which external battery is used, we get an increase of range and maximum speed. Please note that the additional battery is connected only with 2 power wires, without any data lines. On the one hand, this is convenient, because you can equip an additional battery with the cheapest BMS. On the other hand, as a result, we don't have information about its current state, for example, the temperature or voltage of each parallel. Therefore, in place of this data, just static numbers are displayed. The temperature is always shown as 20 degrees, and the voltage of the parallels is calculated by simply dividing the total battery voltage by its configuration. The current consumption could be measured, but in order to reduce the cost, I refused this. So the current and power are displayed as 0. Now I'll say very briefly about the charge consumption algorithm. Everything is very simple. If the internal and external batteries have different voltage levels, firstly the current will be consumed from the higher voltage battery, and then when the voltages are aligned, the current will be consumed from both batteries equally. Well, here is such an interesting and useful operation mode. The next option is a single external battery, and to demonstrate it I have to open the cover back and disconnect the internal battery. What is this mod useful for? Well, for example, if the original battery is broken. Another feature is that you can take the battery off and carry the scooter by a plane. By the way, as I know that even bus carriers don't accept electric vehicles with a battery to the luggage. So in general this is a very exotic option, but of course it can be useful. The next option is very similar to the second, most important mod. The difference is that inside is not an original battery, but a custom one, which was installed there either due to a malfunction of the original battery or to increase their capacity. This is useful because there is no need to use a specialized smart BMS for this custom battery, and the adapter operates as a BMS emulator for it, besides the additional battery connection function. Well, the last option is the same as the previous one, but without an external battery. The device operates exactly as a BMS emulator. So, I will briefly list all possible options. The first option, when only the original internal battery is installed, if we go to a nearby store for bread. The second option is when the original internal battery is installed inside the scooter, and an additional one is installed outside, if you go somewhere far away. The third option is using a single external battery, for example, if the original one is broken, or to carry the scooter by plane taking off the battery. The fourth option, when the original battery is replaced with another one without a smart BMS installed, and the device operates as a BMS emulator for this battery. The last option is when the original battery is replaced with another one without smart BMS, and there is also an external additional battery installed. I thought for a long time how to name this device. Universal adapter for installing an additional external battery with hot plug connection support sounds cool. But I hope this device will become popular in the world, so a convenient short name is required. I was sitting and thinking for an hour, but couldn't think of anything, and then I decided to ask my girlfriend for help. Without thinking twice, she said, "Take it easy, if you don't know how to name something good, name it Rita." So, meet Rita. Rita likes big voltages and long ranges. Another short question that needs to be cleared is about battery charging. Rita allows you to charge the external and internal batteries simultaneously through the standard scooter charge port. That is, you don't need a special charging port at the external battery or take it off for charging. Just plug the charger into the standard port of the scooter and both batteries will be charged. But what if the extra battery with increased voltage is used, for example 12S? In this case, of course, you need a charger with increased voltage too. You can either buy a new one or modify the original one, it's quite easy. Check the video description for a link on the modification tutorial. And then use the new charger as usual. Just plug it into the scooter charge port and the BMS of the internal battery will stop charging when it reaches 42 volts, while the additional battery will charge up to 50 volts. And the last question for today, what about 15S additional batteries? And generally, what is the voltage limit for an additional battery? I will answer this way. 15S battery can be connected, but there are some difficulties, and I don't want to overload this video with it. I will release a standalone tutorial later, and explain in details how to connect an additional 15S external battery using Rita. For now, just remember 3 simple conclusions. If you use an external 10S battery, you will get an increase in range, and you may just plug it in without worrying about anything. If you use an external 12S battery, you will get an increase in range and also the maximum speed by 20%, but you have to buy a new charger or modify the original one. If you use an external battery of more than 12S, then it's necessary to modify the scooter controller and connect Rita a special way. I will make a standalone tutorial about this. Well, it was a very long video, densely full of information. I hope I managed to explain you everything clearly and you didn't get bored. The next video will be much shorter and simpler. I will demonstrate in tiny details the process of installing an additional battery, which bag to buy, how to mount it, how to connect and configure everything, and finally I will write and check the real increase in range and maximum speed. So subscribe to my channel and then you will not miss interesting news. See you!